Hello, welcome back, and it's time for another video lesson. So, first item on the agenda, we have been talking about mass and volume because remember on the last video, I talked to you a little bit about density and how it's important to know the density of an object in order to be able to determine what it's made out of, like in Archimedes' case, where he needed to know if it was a pure gold crown or not. So, I haven't actually told you how to calculate the density using the mass and the volume, and that is today's lesson. So let's get started on that. So what is density is our first question. Density is the compactness of an object, and we need to consider the two measurements that we've been talking about so far, mass and volume. So in order to know how tightly packed the atoms of an object are, we are looking at the mass, how heavy it is, and the volume, how much space it takes up. So if there's something that is small and compact, that means you can pack a lot of atoms of that element in that space. That means it's a very dense object, like for example, gold, or any kind of metal. They tend to be quite dense. So coins tend to sink in water, even if they're the smallest kind, like the dimes, they can sink. So why is that? The reason is it has a lot of mass in a small amount of volume. However, when you think of something like a ship, ships are very, very large, so they have a lot of volume. And in comparison to the volume, the mass is not as large. So they float. The equation to be able to tell what the density of an object is based on the mass and volume is density equals mass divided by volume. Also, D equals M over V. Simple enough, it's just division. Don't worry, I know math can seem scary, but it's not that bad. It's just a division. And you have calculators now, so you're fine. So, if we are calculating density using division, it should be simple, right? Make sure you remember the equation. Mass divided by volume, not the other way around. If you confuse the order, that can give you the wrong answer. So be very careful. You're always dividing the correct value by what you have in the volume, and that will give you your density. Now, sometimes the question will not ask you for the density. It'll ask you for one of the other two, and we'll have to change it up just a little bit. But don't worry, I'll take you step by step. How do we find density? First, you find the mass of the object. You put it on a balance and you see what the mass is. Then you find the volume. If it's a regularly shaped object, you calculate it. And if it's an irregular shape object, we talked about last time using water to determine the displacement of the water will tell you the volume of the object. And then you divide those two numbers. Not too bad, right? So you've done some practice on reading the measurements of mass and reading the measurements of volume. So now that you're able to tell how to find the mass and how to find the volume, calculating the density should be simple. We have an even easier way to help you understand that, the density triangle. So whenever you see these triangles, don't get scared. I know you've probably used them in math before, and if you haven't, I'll quickly walk you through how to work with them. These density triangles can be used to calculate the mass, the density, or the volume, any of them. And if you always draw your triangle when you have to solve one of these problems and you take it step by step, it'll make your life simple in knowing what you're supposed to do with the other two variables. So a way to remember how to write these letters in order in the correct spots on the triangle, we always go from top, down, over. So, monkeys don't vacuum. Monkeys don't vacuum. We move in an L shape down to the right. So monkeys goes at the top of the triangle, don't on the bottom left, vacuum, V on the right. So always an L shape. Monkeys don't vacuum. M, D, V. You know the order of where to put the letters in the triangle. Now, if you take a look inside, you have those division signs. So you would either divide mass by density or mass by volume, depending on what you're looking for. And over here, if you're looking for the mass, you multiply the other two, density times volume. But let's not complicate things just yet. I'm just showing you what the purpose of this is, to know which equation you're using whenever you're looking for one of the three variables. Right now, just remember the order: monkeys don't vacuum. M, D, V. Now that we have that, let's look at an example. I need to calculate something. I am given in this example a few bits of information here and there. If the mass of an object is 35 grams and it takes up 7 centimeters cubed of space, calculate the density. So if I'm being asked for the density, something I can do is, I know I have my triangle over here. Let's look at how would I know what I need to use in this problem. So if I'm looking for the density, what I would do is put a line through the density. That's what I don't know, what I want to know, right? So I should have information on the other two variables. So mass, am I given the mass? Yes. And volume, I have units of volume here, centimeters cubed. So yes, I have mass and volume. That means I can solve the problem. Now, if I'm looking for density, what is the operation being used in between mass and volume? Division. So now I know my equation. Density is going to be equal to mass divided by volume. Now my mass is 35 grams and my volume is 7 centimeters cubed. So my density is going to be 35 divided by 7. And since our mass is in grams and our volume is in centimeters cubed, we have to include units. Units are always very important. 35 grams, 7 centimeters cubed, 35 divided by 7 is 5. So our answer is going to be 5. And the units, you can't really mix those two, so you have to leave it expressed that way. So grams per centimeters cubed. I'm aware that's a very terrible 3. It's okay. So that's our answer. That's how we solve that. If the triangles are helpful to you, what you could also do is just put the numbers next to those and then do the operation. So mass, we said, was 35 and volume is 7. And same thing with the units. Keep your units, grams and centimeters cubed. And then the operation here is division, so you know you're supposed to divide. Simple enough. Let's move on to another variable. Now, what if I want to calculate the mass? What if I'm told the density, but I'm looking for the mass of the object? So in this case, we would now cover something else up, right? So if we're looking for mass, we cover up the mass sign, and we're looking at the other two variables there. So we have density and volume, and the operation between them is a multiplication sign. That means mass is going to be density times volume. So, example 2, we have Jill has a book and the book has a density of 2 grams per centimeter cubed. That's our first source of information. Every single time you see a number, highlight it, underline it, do something to it so that you know that's going to be information you may be able to use later to calculate something. And we're getting told that that's the density, so that's important to know as well. And then, and a volume of, so now they're telling us the volume is 2 centimeters cubed. What is the mass? So now what we're looking for is the mass. So since we're looking for the mass, that's what we cross out in this triangle. That's what we don't know. So we write out the information we do know. So we know that the density is, the density is 2 grams per centimeter cubed, and our volume is 2 centimeters cubed. Now again, the operation between those two is a multiplication. So in this case, we would have mass equals density times volume. In this case, density is 2 times volume is 2. 2 times 2 equals 4. Now, something that's important for you to be able to tell is what units are we using. We know that the units for mass are grams, but just in case you didn't remember that, if you do the same operation with the units, you'll get the result. So here, this is grams per centimeter cubed times centimeters cubed from the volume. So what ends up happening here is when we multiply these, this cancels out with that and you are left with grams, which makes sense because mass is measured in grams. So there we go. That's how you would find mass using density and volume. Now, what if it's the last variable, volume? What if we're looking for volume? Same deal. So now, if we are looking for volume, if the question asks for volume, what we would cover is that V. And so the operation left in between the mass and the density is a division sign, which means volume equals mass divided by density. You always divide the top number by the bottom number, not the other way around. That will give you the wrong answer. And let me illustrate what that would look like with example 3. So here you have 5 and 2.5 are your two numbers. 5 divided by 2.5 is 2, but 2.5 divided by 5 is 0.5. So 2 and 0.5 are two very different numbers. So be careful you are using the correct division here. So let's look at our example. Example number 3 says, what is the volume of a marble that has a mass of 5 grams and a density of 2.5 grams per milliliter? So here, it is asking us for the volume. So the volume is what we want to know. So the volume is what we cross out over here. That's what we want to figure out. So it tells us we have a mass of 5 grams. So the 5 goes with the mass. And a density of 2.5 grams per milliliter. 2.5 for density. And so in between those two, we have a division sign. So we're going to divide 5 divided by 2.5. And 5 divided by 2.5 is 2. Now, what's the unit of volume? Remember, we have a few units for volume. So to make sure, look at the units here. We have mass in grams. And then in the bottom, we have grams per milliliter. So what happens here when we are dividing, the grams are going to cancel out. Our unit is milliliters. 2 milliliters. That's our answer. It's that simple. I know right now it probably seems very intimidating and very difficult, but trust me, it's going to be okay. It's not that hard. It's just multiplication and division. Just making sure you're multiplying the right numbers and dividing the right numbers in the right order, and then you'll be okay. Okay, so just carefully read your problems, put the numbers with your triangle, draw your triangle every single time you answer a question. No, I'm not Illuminati, but triangles will get you through the math in the math part of our course this year. So write your triangle in every single problem you have that has to do with density, mass, or volume, and that will save your life 95% of the time. Okay, you'll be fine. And if you have any questions, I'll see you in class tomorrow. Take care. Bye.